Okay, so let's say we have an LC circuit, and at some moment in time, the current in the inductor, the current in the circuit is 1/4 of the maximum value. So here is our circuit, here's our inductor, here is our capacitor, and we'll label them like that. So we're in a situation where we have that the current is 1/4 of the maximum possible value in the inductor, and we want to know what is the fraction of the total energy that's in the capacitor at that moment. In other words, the energy in the capacitor to the total energy in the LC circuit. That's what we want to know. Okay, so we're looking for a fraction of energy. That's a pure number. We don't actually have to know the values of L and C, or of I max for that matter, but we need to figure out how to relate fractions. So the total energy in the LC circuit is the energy in the inductor, which is L times I squared over 2, plus Q squared over 2C for the capacitor. That's equal to the total energy in the LC circuit. So the total is constant, but the energy is shared, or sort of oscillates between the inductor and the capacitor. We could rewrite this as the energy in the inductor, EL, plus the energy in the capacitor, EC, is equal to the total energy in the circuit, ELC. And in terms of fractions, right, we just divide by the total energy. We divide everything by the total energy, EL over ELC, plus the energy in the capacitor over the total energy, ELC. That's what we're looking for. This must be equal to 1. Right, so in terms of fractions of energies, the fraction of the total energy in the inductor plus the fraction of the total energy in the capacitor must equal to 1. So we want EC over ELC. That means that if we go through energy conservation, that must be 1 minus EL over ELC. So the question is, can we get EL over ELC? And the answer is yes, we can get it from this information, but we need to be able to write both EL and ELC in terms of this ratio. So we can write EL in terms of I and ELC in terms of I max, and then we can incorporate this 1/4 into the answer. Right? So that number is going to affect this quantity. How does it do that? Well, we know that when the current in the circuit is maximum, or the current in the inductor is maximum, we have Li squared over 2 is the energy in the inductor. So I replaced I with I max, but we know that there's no charge in the capacitor, so we have plus 0. That's equal to ELC. So an expression for the total energy in the LC circuit is Li max squared over 2. So we don't need to know what L is or what I max is. We can now calculate EL over ELC as, right, EL is Li squared over 2, and ELC is Li max squared over 2. The L and the 2 will cancel, and we'll get I squared over I max squared. But that's just the square of this quantity, so this is 1/16. So our answer is the fraction of the energy in the capacitor at that moment is equal to 1 minus 1/16. Right? The rest has to be in the capacitor, and so we have most of the energy is in the capacitor. And so 15/16 of the total energy is in the capacitor at that moment.